Have you ever seen an iceberg, maybe in a photograph or a nature documentary? They are massive structures of ice just floating in the ocean. It makes you wonder, how do they not melt instantly? It's a question that speaks to the amazing power of our natural world, and it's a question with a fascinating answer. The universe is full of wonders like this. We just need to be curious enough to ask the right questions. And when we do, science is there to help us understand. So let's dive in and explore the science behind these icy behemoths. Let's uncover the secrets of why icebergs don't melt instantly. Icebergs. These majestic floating giants are more than just frozen water. They are the remnants of ancient glaciers, slowly making their way through the Arctic waters. Each iceberg tells a story of time, pressure, and the relentless forces of nature, etched into their icy forms. They are more than just chunks of ice. These formations are the result of centuries of snowfall, compacted into dense ice over millennia. As they drift, they carry with them the history of the Earth's climate, locked within their frozen layers, preserving secrets of the past. They are colossal fragments of glaciers and ice shelves. These massive ice structures are born from the slow, inexorable movement of glaciers which flow like rivers of ice, carving valleys and shaping landscapes as they go, leaving a mark on the Earth. These icy giants break off from their parent bodies in a process known as calving. This dramatic event occurs when the edge of a glacier advances into the ocean, and the pressure causes a massive chunk to break away, creating a new iceberg. Imagine a giant glacier slowly flowing towards the sea. The pressure builds. Over time, the weight of the ice and the force of gravity become too much to bear. The glacier creaks and groans under the strain, a prelude to the inevitable. Then, with a thunderous roar, a massive chunk breaks free. This is the birth of an iceberg, a moment of both destruction and creation, as a new giant is set adrift in the ocean, beginning its solitary journey. That's an iceberg being born. As it plunges into the sea, it creates waves and ripples, a testament to its immense size and power. This new iceberg will now begin its journey carried by ocean currents, a silent traveler of the seas. And these are not just small chunks. Icebergs can be colossal. Some of these floating giants are so large that they can be seen from space, their white surfaces reflecting sunlight and standing out against the dark ocean, a beacon of the Arctic. Some are bigger than skyscrapers. Imagine a structure taller than the tallest buildings in the world, drifting silently through the Arctic waters. These icebergs are true giants, dwarfing everything around them, a testament to nature's grandeur. Some even dwarf small cities. But here's the catch. Despite their enormous size, what we see above the water is just a fraction of their true mass, a mere glimpse of their full scale. We only see a small part of them. The majority of an iceberg lies hidden beneath the surface, out of sight. This hidden mass can be up to 10 times larger than what is visible above the water. A hidden giant. The tip of the iceberg, so to speak. This phrase has become synonymous with the idea that what we see is only a small part of a much larger whole. In the case of icebergs, it is literally true, a perfect metaphor. The majority of their mass lurks beneath the surface of the water. This hidden bulk is what makes icebergs so dangerous to ships, as the unseen ice can stretch out far from the visible tip, a silent threat, hidden from view, like a secret waiting to be discovered. These underwater giants are a reminder of the power and mystery of nature, and the incredible forces that shape our world, a testament to the Earth's enduring strength. Here's where it gets really interesting. When you look at an iceberg, it's hard not to be amazed by its sheer size, and the fact that it floats so effortlessly on the ocean's surface. But have you ever stopped to wonder why that is? How can something so massive float? How can something so massive float? It seems counterintuitive, doesn't it? You'd think that such a gigantic chunk of ice would sink straight to the bottom of the ocean. After all, we know that heavy objects tend to sink in water. Shouldn't it sink like a stone? When you throw a stone into a pond, it immediately plummets to the bottom. So why doesn't the same thing happen with an iceberg? The answer lies in a simple concept: density. Density is a measure of how much mass is contained in a given volume. It's a fundamental property of matter that explains a lot about how objects behave in different environments. Density is all about how tightly packed the matter is in an object. For instance, water molecules are packed more closely together in liquid water than they are in ice. This difference in molecular arrangement is key to understanding why ice floats. Think of it this way. Imagine you're holding two boxes that are exactly the same size. One box is filled with feathers and the other is filled with rocks. Imagine a box full of feathers and another box of the same size full of rocks. Even though the boxes are the same size, the box of rocks is much heavier, right? The box of rocks is much heavier, right? That's because the rocks are denser. They have more mass packed into the same space compared to the feathers. That's because the rocks are denser. They have more mass packed into the same space. This concept of density helps us understand why some objects float while others sink. They have more mass packed into the same space. When it comes to ice and water, the same principle applies. Ice is less dense than liquid water because its molecules are arranged in a way that takes up more space. Ice is less dense than water. This means that a given volume of ice weighs less than the same volume of liquid water. As a result, ice floats on water. This means that a certain volume of ice weighs less than the same volume of water. When you place ice in water, the water supports the ice, allowing it to float, and that's why ice floats. It's a fascinating phenomenon that can be explained by the simple yet powerful concept of density. It's all about the density. Understanding this concept not only helps us grasp why icebergs float, but also opens the door to a deeper appreciation of the natural world and the principles that govern it. The more we understand these principles, the more we can marvel at the intricacies of our environment. Section 4. Chilly waters, slow melt. Now let's talk about temperature. Icebergs form in the polar regions where the ocean water is incredibly cold. We're talking about temperatures near freezing. These frigid waters play a crucial role in slowing down the melting process. Think about it, it takes a lot of energy to melt ice. That's why we use heat to melt ice cubes in our drinks. The frigid ocean temperatures just don't provide enough energy to melt icebergs quickly. It's like trying to boil a pot of water on a very low flame. It takes a long time. Section 5. The sun and the sea's slow dance. But it's not just the cold water. The story of an iceberg's life is a complex interplay of various natural forces, each contributing to its eventual fate. Sunlight and ocean waves also play a role in the melting process. These elements, often seen as gentle and serene, are powerful agents of change, working tirelessly. Sunlight, of course, provides heat. This heat is essential in the gradual melting of the iceberg's surface, slowly transforming it. But ice is surprisingly good at reflecting sunlight. This reflective property, known as albedo, helps icebergs resist melting to some extent, preserving their form. Have you ever noticed how bright a sunny day can be with snow on the ground? This brightness is due to the high albedo of snow and ice, reflecting most of the sunlight. That's because snow and ice reflect a lot of sunlight. This reflection helps to keep the ice cooler, slowing down the melting process significantly. Ocean waves, on the other hand, are like gentle sculptor's tools. They may seem harmless, but their constant motion wears down the iceberg's edges over time. They constantly lap against the iceberg, slowly eroding it over time. This erosion is a continuous process, shaping the iceberg's form gradually. It's a slow and steady process, but it does contribute to the iceberg's eventual demise. The waves chip away at the iceberg, bit by bit, day by day. But even with the combined forces of sunlight and waves, icebergs are remarkably resilient. They endure these natural forces with a quiet strength and grace. They can last for years, even decades, drifting across the ocean. Their journey is a testament to the enduring power of nature and its relentless cycles. Eventually, however, the forces of nature prevail. The iceberg breaks apart, its pieces floating away to continue the cycle, each fragment on its own path. These smaller pieces will also face the same forces, slowly melting and eroding until they too disappear, becoming part of the ocean once more. The ocean is vast, and the cycle of icebergs is a small but significant part of its story. Each iceberg's journey is a slow dance with the sun and the sea, a dance of survival. This dance is a reminder of the delicate balance in nature, where even the most seemingly insignificant elements play a crucial role in the grand scheme. As we watch the ice melt and the waves crash, we are witnessing the slow but relentless power of nature at work, a force that shapes our world. It's a process that has been happening for millennia, a testament to the ever-changing face of our planet, a cycle that never ceases. The sun and the sea in their slow dance shape the world in ways we are only beginning to understand, revealing the intricate beauty of nature. And so, the dance continues, a beautiful and powerful reminder of the natural forces that govern our world, a dance that is eternal. Section 6. Echoes in the ice. And here's something truly amazing. Icebergs are like time capsules. Trapped within their frozen depths are tiny bubbles of ancient air. Scientists can study these air bubbles to learn about Earth's atmosphere from thousands, even millions of years ago. These air bubbles are like little windows to the past. They tell stories of ancient climates, volcanic eruptions, and even the composition of the air our ancestors breathed. It's a reminder that icebergs are more than just beautiful objects. They are valuable archives of our planet's history. Section 7. The universe in a frozen tear. So, the next time you see an image of an iceberg, take a moment to appreciate its beauty and complexity. Think about the forces that created it, the immense power of nature at work, the science that keeps it afloat, and the delicate balance it maintains, and the secrets it holds within its icy heart, waiting to be unveiled. It's a reminder that our universe is full of wonders, both big and small. All we need to do is look closely, ask questions, and never stop exploring. The universe is waiting to be discovered, one cosmic question at a time. Subscribe, like, and share for more videos about mystery things. If you have any questions, tell me in the comments.